AP Chemistry, Unit 3.13, the Beer-Lambert Law. Absorbance is how much light is going to be absorbed, and we can measure the concentration of a colored substance by seeing how much light can be passed through it, otherwise known as how much light is being stopped by the solution. So that relationship, how much light is actually making it through versus how much light is absorbed, is able to help us figure out what the concentration of that colored solution is. We do this via a spectrophotometer or a colorimeter, which can be used to measure the absorbance. This is what the inside of a spectrophotometer or a colorimeter could potentially look like. So we will have a light source, which will be an LED, which will give off all wavelengths of visible light. We will then utilize an absorption filter, otherwise known as a wavelength selector, to select the specific color and specific wavelength of light that we want to use for our test. So here we have 620 nanometer light being what we have selected for. Then we will have our sample solution, and that light will pass through the sample solution into a photoresistor, otherwise known as our detector, which will then go into a multimeter which will read for resistance, and that's what the inside of a spectrophotometer or colorimeter will look like. In order to determine the best wavelength to use to measure your sample, you would generate a graph of absorbance versus wavelength. It could look something like this, where you will run through all of the options for the wavelengths of light and see the relative absorbance that was absorbed by that sample. Whichever is your peak absorbance is going to be your best wavelength. You're going to want to choose a wavelength that gets you as close as possible to an absorbance of 1.00. Using absorbance to calculate concentration, you can make a calibration curve with a standard solution concentration and the corresponding absorbance value. You can then place your unknown concentration of solution on that chart to go ahead and figure out what the concentration should be based off of the absorbance. Your graph should be linear, and the slope of the line is going to be known as your molar absorptivity constant. This is the Beer-Lambert equation, where A is equal to absorbance. Your epsilon is going to be your path length, which is typically the width of the cuvette, which is what you are putting your solution into. It's typically around a centimeter. B is going to be your molar absorptivity constant, which is your slope from your curve. And then C will be your concentration. Some common errors that you could have while you are working with Beer-Lambert include flushing the cuvette with water. If you were to flush the cuvette with water in between samples, some of the water will remain in the cuvette, which will slightly lower the overall concentration of your sample that you're testing, as it will dilute your next solution. So instead of rinsing with water, what you should do is use your new concentration, your new solution, to rinse out any leftover of the previous solution. Another common error is failure to calibrate using a cuvette filled with the same solvent. So if you don't calibrate your spectrophotometer with a cuvette with that specific solvent, typically it's going to be water, then you could accidentally include some absorption that is due to the cuvette itself or the solvent itself, which would lead to higher concentrations, higher calculated concentrations than would truly be there. And so what you should do instead is to make sure that you use a blank cuvette This would be filled with your solvent in the cuvette that you're going to be using for your measurements, and that will allow you to go ahead and subtract out any of the absorbance that is specifically from the solvent itself or the cuvette itself. The last common error is failure to wipe off the cuvette with a tissue before running the sample. The reason that this is a problem is as you're touching the cuvette, you could leave fingerprints and leave small amounts of oil on the cuvette. That could potentially increase the absorption of the spectrophotometer and throw off your measurements just because of the extra fingerprints or oil that you have on the cuvette. So what you should do instead is to make sure that you use a Kim wipe to go ahead and wipe your cuvette before every run of the machine.